Hey everyone, thank you for watching this video. I'm Ujjwal and I'm currently pursuing my master's degree in data science at University of Maryland, Baltimore County. This is an introductory presentation on the Data Science Capstone Project that I'm undertaking under the guidance of Dr. Chaojie Wang as part of my program curriculum at UMBC. I aim to classify documents through a multimodal AI approach, which will utilize image features and textual features of the image data. Multimodal AI is a new AI paradigm in which various data types, image, text, speech, numerical data, etc., are combined with multiple intelligence processing algorithms to achieve higher performances. Before I get started with my project explanation, I would like to introduce myself. I'm currently enrolled in Master of Professional Studies in Data Science degree program at UMBC. I'm also working as a global ambassador at the Center for Global Engagement and graduate grader at the Data Science Department. My ambition to build a career in the field of data science and machine learning has given me a chance to learn amazing skills like Python, SQL, MATLAB, Tableau, and Microsoft Azure. I've taken up and completed many challenging projects till now. For California Drought Analysis Project, I analyzed 20 years of meteorological data and built a machine learning model using random forests and voting ensemble techniques to predict the presence and severity of drought in a region. For Twitter sentiment analysis and stock price prediction, I analyzed how Twitter sentiments are correlated with stock prices of companies and then built a multivariate time series forecasting model with the help of LSTM models, which utilize the previous day's stock prices values along with the sentiment values to predict the next day's stock prices. Now, I would like to talk about my capstone project. First, let me explain a little about document classification. A document is an item of information that has content related to some specific category. Product photos, commentaries, invoices, document scans, and emails all can be considered documents. Document classification is a process of assigning categories or classes to documents to make them easier to manage, search, filter, or analyze. Document classification tasks can also be perceived as a collaborative task dealing with text classification and visual classification because a document has an associated visual structure and text related to its domain. Text classification concerns defining the type, genre, or theme of the text based on its content. Depending on the task, complex techniques like NLP can be used to analyze words and phrases in context and understand their semantics. Visual classification focuses on a visual structure of documents, employing computer vision and image recognition technologies. Document classification has become crucial for various kinds of organizations, whether business or government, as it not only helps us in saving information but also helps us find these documents whenever required. It is becoming an increasingly effective way for collection and storage of data that can become a rich source of business analytics. For example, a customer services team might use document classification to ensure incoming support tickets go to the right individual. An accounting firm might use invoice classification to assign expenses to the correct department. An automated document classification will be fast, efficient, and it will free up human resources for better brainstorming works in any organization. I'm using document structure learning dataset available on Kaggle by Patrick at Audrias. This dataset was introduced by Jayant Kumar, Pengie, and David Duerman in paper titled Structural Similarity for Document Image Classification and Retrieval in November 2013. This dataset was also used in the paper titled Learning Document Structure for Retrieval and Classification at International Conference of Pattern Recognition in 2012. It is a 2 GB dataset with 3492 documents belonging to 10 different classes, which are advertisement, email, form, letter, memo, news, note, report, resume, and scientific. These are some sample images showing a random instance of each type of document. It can be observed that most of the documents in this sample set has some associated image structure. Through this project, I want to find how the manual document classification compares to automated document classification. I also want to understand how automated document classification can impact an organization. And I want to explore whether a multimodal approach of combining computer vision, OCR, and NLP will give better results in document classification than using each of these aspects individually. First, I will prepare a dataset to retrieve the text present in the images using optical character recognition libraries like PyTesseract. Then I will pre-process the text and execute feature engineering tasks. I will clean the text by removing punctuations, numbers, white space characters, small insignificant words with lengths up to 3 characters, and then use that text for analysis, generating word clouds and lexical dispersion plots, and building the machine learning model for classification. Then I will train the machine learning models for individual features and analyze their performance. For example, I can train convolutional neural network on image data for classification and train naive Bayes model on text data for classification. Then I will work on combining image and text features to make a collaborative model for classification. Finally, I will perform hyperparameter tuning to improve the final model's performance. Now I will discuss the results of initial exploratory data analysis that I have performed. I have conducted EDA in two phases: EDA of images data and EDA of text extracted from the images. I have analyzed the format of images, whether they are .jpeg, .png, etc. I have analyzed the types of images, whether they are grayscale or color, and I have analyzed the dimension data of image like height and width. I've cleaned the text, analyzed the length of text, generated word clouds, and also generated a lexical dispersion plot for top 10 frequent words. Wherever possible, I've done these analyses both collectively, that is using all the data, and individually, that is for each label separately. I have a biased data with maximum number of images for a memo and a minimum number of images for a resume. The instances of each label can also be observed in these slides. It can be observed that memo, email, and letter have almost comparable number of instances. All the 3482 images are JPEG and grayscale images. There are 325 unique dimensions for height of images and 39 unique dimensions for width of images. This slide shows the maximum height dimension, the minimum height dimension, and most frequent height dimension for each class of image. The most frequent height for each class of image is same, which is around 20 to 92 pixels. This slide shows the maximum width dimension, the minimum width dimension, and the most frequent width dimension for each class of image. The most frequent width of ADVE, email, form, news, resume, and scientific is same, which is 1728 pixels. The most frequent width for letter, memo, note, and report is same, which is 2544 pixels. This slide shows the distribution of disk space occupied by the images. As evident, the distribution is right skewed. I detected 26 languages in the dataset. I also found that there were no text present in 21 images. Since I will be focusing on English text, I will drop all the images that contains other language text. The text length distributed graph, the text length distribution graph is also right skew. Word clouds and frequency distribution plots helps in observing the highly occurring words in any corpus. Tobacco, date, and research are the most frequent terms in all the images. Information, date, and phone are the most frequent terms for note. Date, number, and Morris are the most frequent terms for form. Subject, sent, and date are the most frequent terms for email. Tobacco, research, and deer are the most frequent terms for letter. Said, tobacco, and smoking are the most frequent terms for news. Smoking, cigarette, and general are the most frequent terms for ADVE. Subject, Philip, and Morris are the most frequent terms for memo. University, research, and medicine are the most frequent terms for resume. Cells, study, and protein are the most frequent terms for scientific, and tobacco, smoking, and cigarette are the most frequent terms for report. Lexical dispersion is a measure of how frequently a word appears across the parts of a corpus. This plot shows the occurrences of top 10 most frequent words and how many words from the beginning of the corpus it appears, which is also called word offsets. For example, the word university doesn't appear at all in note or form. It also appears very less in memo. Initially, I tend to implement the convolutional neural network, AlexNet and ResNet for image classification purpose. For document classification using text data, I can utilize models like XGBoost or random forests. Since it is a classification problem, I can analyze confusion matrix, accuracy, precision, recall, F1 score for judging a model's performance. Through this project, I intend to develop a state-of-the-art multi-modal document classifier which can leverage both types of data, that is visual and text, for making a reliable final prediction. I've already worked on image processing and natural language processing, and I feel that working on a data science and machine learning problem that entails the use of both these aspects will equip me for future multimodal AI tasks. These are the references I've used so far. I got the PPT template from Slidesco, which is an amazing resource for captivating PPTs. I got the icons from FreePic, which is a great resource for creating infographics. Again, I would like to thank you for viewing this presentation.